So we need to rearrange that one in descending order. The way I knew it wasn't in descending order was just, I noticed that they all just had the letter y, and then this didn't have x, this had nx, and this had like x squared. So I thought, well, that's not in descending order. So I would put it in descending order first, so that whenever we factor out the GCF, notice that first term is negative. I don't want a negative in my first term, so I want to factor out a negative. And what can they be divided by? 2. And then they all have the letter y. Charlotte, you're not bothering me or anything, but I just want to tell you you're not muted. I just heard you enter and saw you. So hi, I'm glad you made it.
Sorry.
No, you're fine. Okay, so we factor that out. Remember, it needs to go in front of the parentheses, and then we can go show that we're dividing by that GCF. So negative 4 divided by negative 2 is a positive 2, and your y0 out. So we have 2x squared. Negative divided by negative makes that a negative. It's like a 1, but since we have x, we don't have to put the 1. And then negative or positive divided by a negative makes that a negative 15, and my y0 out. So because we're factoring, you can see it, look at it like there's a 1 there if you want. If it helps you remember. But because we have a 2 in front of our x squared term, remember we look at this now after we factored out our GCF. We look to see, can this factor more, which it can. And because of the 2 that is in front of our x squared term, we want to go ahead and take it to the back and multiply it with that slide step of slide and divide. So I always just keep rewriting 2y, that way I don't forget it. And so if I could pick that 2 up and move it to the back, we would just have x squared minus, I'll go ahead and write 1x minus 30. And then we can factor this using that product sum method that we learned about. So since that's a negative 30, we know we're using opposite signs. And I know if I take 5 times 6, that's 30, a positive 5, and a negative 6 makes that negative 1 middle term. Just remember, if you can't go directly to the pair of factors that make the middle term, then it doesn't take but just a second to list all the possible factors of 30. But sometimes you might, if you're quick at it and you practice it more, you're going to probably recall the factors that you need quicker. So I'm going to leave my negative 2y out front all the way till the end. So I'm going to split my x's apart, x and x, and I'll plug in plus 5 minus 6. So remember we did our slide and changed that constant to a 30 by multiplying, so we need to undo its factors by dividing by that same number of 2. So we have negative 2y times, 2 doesn't go into 5, so we want to pull it up in front of x, so 2x plus 5. And then we can reduce, 2 goes into 6 3 times, so x minus 3. So hopefully that'll be a little bit of a reminder, you know, since Tuesday. If you haven't started your homework yet, at least you kind of went over a slide and divide one more time today before you do your homework today. We're going to turn the page and we get to learn how to solve quadratic equations. I'm leaving this here because I see people still writing, and that's okay. So I'm just going to talk while you're writing. But we're solving quadratic equations by factoring first. We do this 4 different ways, and every way has a specific way that it needs to be set up to start. So quadratic equations have like an x squared in them, like an exponent that's bigger than x, basically, an x squared. And so if it's got an x squared, this means there's 2 solutions, because that means there's 2 x's, right? So when we solve by factoring, we need to get everything all on the same side, and that's called standard form. This will say factor the left side. It could be or the right side, depending on which side you zeroed out and moved stuff over to if you had to. What I mean by that is standard form could look like x squared plus 5x minus 10 or equals 0, or it could be 0 equals all of that on the other side. Standard form just means you have 0 on one side of the equal sign. So if you look at number 1, it's not in standard form, right? We need to move something over. So I would say, let's move this over here since this x squared is already positive. Remember, you're wanting to move this entire term. We're not trying to take 7 away from the x, so you're going to subtract 7x. So we get x squared minus 7x plus 10 equals 0, because 7x minus 7x was 0. That's what we want it to look like. So this is where we'll get to review a little bit of factoring, because once you get it all on the same side, we need to factor the polynomial that we have. So since this is a positive 10, am I using same or opposite signs when I factor?
Same.
Same? So we're so good at that now. Look at us. So we'll split our x's apart, x and x, and I know 2 times 5 is 10, and if they were both negative, would they make that negative 7?
Yes.
Yes, so those are the pairs that we're using. So negative 2, negative 5. So the next little bullet up there, if you read any of that, it says use the zero product property to set each factor equal to 0. So all that means is you're taking this factor over here, x minus 2, setting it equal to 0, and then this one gets its own equal 0 as well. You don't really have to put those lines through, I just do, so you know it's like we're pulling it apart now, and each of them get an equal 0. So now we just solve. This is probably where I see the most mistakes. We do really good here, and then we try to say x equals negative 2 or something because we saw the negative 2. Remember, you have to move it over, so it would be the opposite sign, so you're adding 2, so x would be a positive 2. Here we're adding 5. It takes just a second to show that step. You have to add it, so you have to change its sign, so it's a positive 5. In WebAssign, I like to always kind of hit on that. It'll say enter your answers as a comma separated list, so it would look like that. It doesn't matter which number you put first ever. I'll put a WA there so you know that's how you enter it in WebAssign. So number 1, again, first we had to just get everything on the same side, and then we just factored it. This is the easier trinomial factoring product sum method. Set those factors equal to 0 and find the 2 values for x's. Number 2 is not in standard form, right? I would probably move everything to the left because my x squared term is over there and it's already positive over there on the left. So I'm going to focus on moving this one first because I have a like term. If you wanted to do this in 2 steps, I guess you could. I'm going to this time. So 4 minus 2 is 2x. And then equals 5, just so that you can see there's not a like term over here, is there? So you just need to pull it to the side. So 3x squared plus 2x minus 5 equals 0. I usually do that in the same step, but because it looks messy, today I went ahead and just showed it as 2. So that you can maybe read your own notes when that happens. You're just trying to get everything to the left-hand side. Sometimes things are like terms and combine when you do. And sometimes they're not, so you're just subtracting it. So it's just the opposite sign on the other side. But this one is going to have to be slide and divide because there's not a GCF, right? So we get to go practice our slide and divide steps. So we're going to go slide 3 to the back and multiply it by 3. So again, it's like we picked that up, and we have x squared plus 2x minus 15 equals, and I always keep doing equals 0 just like I would if there was a GCF. I know we're not doing anything with it, but just always bring it down. 3. Don't forget, it's an equation. Same or opposite signs?
Opposite.
Opposite signs. So if I take, I'll write it over here, 3 times 5, that's 15. I want a positive 2, so that means I want a positive 5 and a negative 3 in my parentheses. So we set up our 2 parentheses, and we say x minus 3, x plus 5. So we factored that last term. So we need to go divide those factors by 3. So since 3 goes into 3 evenly, we could say that's x minus 1. And this one we can pull 3 up in front, so 3x plus 5 equals 0. So then we just need to go solve for x for both of those x's, both of those parentheses. So you just say x minus 1 equals 0 and 3x plus 5 equals 0. So here you're adding 1 over, so x equals 1. Here we're subtracting 5. So 3x equals a negative 5. And then we finish by dividing by 3. So x equals a negative 5 over 3. Just a side note, I like to point it out. Sometimes I regret it, but we'll see if I regret it later. When you come back up to here, if you look here, the number that you pull up in front of x is the 3, right? And I like to do that in the notes, especially because I think it's good practice with the factoring part of the steps that you're doing. But do you notice that if you would have went ahead and set that parentheses equal to 0, that you would have just been subtracting 5 over 3? I mean, if you can think outside the box of that, you're welcome to kind of stop there. You would have to reduce that one. But I don't know why I point this out. Like every semester, I'm like, I'm going to quit doing that. But it's okay. Like, because we're solving for x, you don't always have to pull it up in front of there, because you know you're subtracting it over. What happens is, when you do pull it up, we did subtract 5 over and we divided and it's the same. I think it's good to be in the habit of factoring it, so we're always factoring it and we never just stop. And that's why I continue to do it in my notes like that. But I've had students in the past say, why don't you just set that equal to 0? So that's for maybe the 2 of you that want to do that. Okay, and then also where I start, I want you to know that sometimes in WebAssign, I think, or maybe in a quiz or a test, if we do this in a quiz or a test, sometimes you will be given the problem in that step. Just like whenever we were learning how to factor by grouping, don't make that harder than it needs to be. Everything's already on the left and it's already equal to 0, right? So if you see it like that, then all you have to do is take it from there. There's no thinking required. You just pull it apart, set them equal to 0, and solve. So sometimes it is given in this step and you didn't have to factor. But like if you look at number 3, it looks like there's parentheses in there already. Because there's stuff on the other side, where this was already equal to 0. Because there's stuff on the other side, I do have to distribute this one and get everything to the same side. So let's go do that. We're going to rewrite x plus 18 on the left, and then x times x is x squared, and x times a negative 6 is a negative 6x. So since my x squared term is on the right this time and already positive, I'm going to choose to move my terms to the right. So I'm going to subtract x, and I can subtract 18. I can show it in the same step because it's not as messy as number 2 was. So 0 equals x squared And remember, that's an understood 1, so this would be a negative 7x minus 18. So now we can just factor it. This one would be product sum because there's not anything in front of our x squared term, so we're using opposite signs. If I take 9 times 2, that's 18. If I want my 7 to be negative, I would put the negative in front of the bigger number. So those are the pairs that we're going to use. So 0 equals, we'll set up our 2 parentheses, x and x, and plug in minus 9 plus 2. So it doesn't matter if you say x minus 9 equals 0 or 0 equals x minus 9 when you're splitting these apart. I like to say x minus 9 equals 0. But remember, you're just giving an equals 0 to both of those parentheses. X plus 2 equals 0, and then we just solve for our 2 x's. So you're just going to add 9 to both sides, so x equals 9. And subtract 2 from both sides, so x equals a negative 2. Okay, so got to review a little bit of factoring. I would say solving quadratics, if the polynomial can factor, this should be the fastest and easiest way to do it. But sometimes polynomials don't factor, and so you wouldn't be able to do this method. If you turn the page, we're learning by the square root property. And this method is really great when, like, if you had a difference of 2 squares. You know, like if you had x squared minus 16 equals 0. That one could be factored because it's a difference of 2 squares, right? Or even if that was a plus 16, because we're going to be working with imaginary numbers, we could actually do this. But what we want to be sure is that our x squared term is isolated. So that's where the starting point matters with this method. You also are going to be working with like binomial squareds. So if you write the word binomial and just put it in a parentheses, squared equals a number. We also want to be sure our binomial, if we have it like x plus 2, x plus 3, whatever it might be, we also want to make sure those things are isolated, just like if it were just the letter x. We want to be sure it's all by itself, and then the number is on the other side. So like if you look at example 4, we already have x squared by itself. So the reason we use the square root property is because I want to know what x is, not x squared. So if you take the opposite operation, which is taking the square root of that, we can find that. And in your calculator, if you don't know that the square root of 225 is 15, remember you can ask your calculator to do it. So x equals 15, but it also equals a negative 15. So that's where the 2 solutions come from. So just like when we were factoring, we had 2 parentheses and 2 numbers that were our answer. X squared, anytime you see x squared with an equal sign in it, you're going to have 2 solutions, whatever method you're using. 2 solutions for everything today. And the reason is if you take 15 and you square that number, you get a positive 225. And again, remember you have to tell your calculator that you're taking the 15 with it. You have to put it in a parentheses in your calculator just like I write it. It is also a positive 225. So that's where the 2 solutions come from when we're talking about the square root property, when it's just a letter squared. A little bit of a review of what if we take the square root of a negative number. So 5 is fine in that we have x squared by itself, but when we take the square root of the right-hand side, remember we cannot take the square root of a negative number. If you tried in your calculator and you put the negative under the radical like it is, it's going to give you a syntax error because it's just not possible. This is where I hope you kind of remember that you had to pull out the letter I from that, and then it would have been like a positive 50. So then we could go simplify the square root of 50. If you're having to do it manually, remember you could take 25 times 2 to make 50. What's the square root of 25? 5. So we have a 5i, and you would leave that 2 underneath. So we have the positive form of that, and then you put a negative in front of the whole part of the term. Like this is called a term. All of that is all together. And then you put it in front of it. How many of you remember seeing plus or minus signs in high school? It would be great if we had a plus or minus tool in WebAssign, but they don't have it. Sometimes I'll write it just to remind you that this is two things, but in WebAssign you have to write it twice with a little comment in between, unfortunately. And that's really annoying when the answers get uglier, because you might have a number plus a radical over 2 or something. But it is what it is, and we can handle it. I think the only thing I like about it not having the plus or minus tool is we remember that these are actually two different things. Sometimes when we see plus or minus in our mind, it looks like one thing. So we haven't had to get x squared by itself yet, but starting with number 6 we do. We don't want a coefficient in front of x squared. So we would divide by 4 because we want x squared by itself. Even though 4 is a perfect square number, I know you can take the square root of 4, we still don't want it there before we ever square root, okay? Because what if that was 3 or 7 or, don't just always get x squared by itself. It cannot have a number in front of it. So that means that x squared equals 81. Then we can go work with the square root property. So you always have to get it in its correct starting form first. Never do anything before. Now we can go take the square root of both sides. So x will equal 9 or negative 9. So kind of going back over that plus or minus while you're writing, maybe taking a brain break. I'm okay on paper, like if you're taking a quiz or a test, if you do it like that. Like I don't need you to write it twice. You can use plus or minus. But in WebAssign, you just need to know that you have to pull it apart and write 9 twice, with one positive and one negative. So we need to get x squared by itself in number 7. So the first thing we would do is move 114 over. So I have 2x squared equals 114. And then what do we do?
Divide by 2.
Divide by 2. Because you're trying to get x squared like it's a 1x squared. So I have x squared equals, and then that would be 57. So we get to finish by taking the square root. Sometimes these radicals don't simplify any further. And you can double check in your calculator if you have the TI 30XS multi-view. But this one doesn't. That means there's not a perfect square number that you can multiply times something to make 57. So you just leave it as the square root of 57, but remember when you write this would be the square root of 57. The negative has to go in front of the radical sign, not underneath. Sometimes, like I said, you may have seen it like plus or minus, and then you put it like this. But in WebAssign, you have to do it twice. Yeah, we need to stretch. I'm tired.
Yeah, I think we should call her quits.
I know. We have a lot more to do.
Oh no.
I know.
We can't just do like
We can be done
minutes early.
We can't leave 40 minutes early, yeah.
Wouldn't bother me much.
Yeah, let's just be done. Okay, binomial squareds. So number 8 is in a good spot. Remember up here I said we need to make sure binomials are also the only thing on one side together. And this one is already like that. So what you need to understand is when we take the square root of these, just kind of coming up here, when I take the square root of 100, I get 10 and I get negative 10. So this is going to make 2 equations. So the answers are not going to be like the positive and negative form of a number. You have to make 2 equations, then go find the number. So the 4 before, we were doing it and it was just the positive and negative form of the same number. It's not that same pattern now. So we have x plus 9 equals a positive 10. You could say and or. I like to write and. X plus 9 equals a negative 10. So because of the square root of 100 can be positive or negative, it makes 2 equations. So when we subtract 9 here, we are saying 10 minus 9 is just 1. But over here, they're same signs, so we get x equals negative 19. We get to end on like quadratic formula, which I bet everybody's really good at, so that hopefully that's encouraging. Okay. Okay, so number 9 is not how we want it to start. We need to get that binomial squared. So just like kind of like number 7, even though that was just an x squared, we still had to like add a constant over, then divide. Same pattern, except for it's a parentheses squared. So I'm going to move my 24 over by adding it. So I have 3 times x minus 2 squared equals 24. And then I get the binomial by itself by dividing by 3. So x minus 2 squared equals 8. So now we're where we need to be to start doing that square root property step. So I'm going to come over here this time and show this. If I take the square root of 8, is that a perfect square number? No. You can't multiply a number times itself to make it. So remember, that's like saying 4 times 2. What's the square root of 4? 2. So we have 2 square roots of 2 and a negative 2 square roots of 2. So that's where the 2 equations come from when we set. This one would be nice, since this isn't a whole number, if we could use the plus or minus stuff. But I still will set it up twice so that we're always just doing it the same way. So if I have x minus 2 equals a positive 2 square roots of 2, and x minus 2 equals a negative 2 square roots of 2, we just need to get x by itself now. So I'm going to add 2 to both sides. It could have been a while since you worked with radicals, so just a reminder that we can't really add these terms together because they're considered not like terms. Kind of like if that radical was an a, this would be like 2a. I can't add 2 to 2a. So I can't add 2 to 2 square roots of 2. They're not like terms. So we just write them as generally, the order doesn't matter, but generally you will see the whole number written first, then plus with the radical on the end. The reason I put plus was because that was the positive form. And then here, you're still adding 2 over here, but the only difference is we have 2 with a minus sign in between. So this is when not having the plus or minus tool gets kind of annoying, because you might have learned to like just write plus or minus 2 square roots of 2 and move that 2 over, and just it kind of looked like one statement. In web assign, you get, you have opportunity to type it in twice of 2 plus 2 square roots of 2, comma, 2 minus 2 square roots of 2. That's how you're going to do that. So that's using the square root property, which as we turn to the next method, the third method is a method that we're going to use a lot later when we start working with circles and stuff. And before we actually learn it, I like to remind you of something you know about polynomials that relates to it. It helps with understanding why we do it. If you had x squared plus 18x plus 81, this is called a perfect square trinomial. Perfect square trinomials can factor down to 1 parentheses squared. Remember when we were just undoing a binomial squared? That's what that would have been. It would have been a trinomial that was factored. And so when we factor this, it's like saying 9 times 9 is 81, and if they were both positive, that would make the 18, right? Perfect squared means your first term and your last terms are perfect square numbers. So if you factored it into 2 parentheses, it would have looked like 2 matching parentheses. And generally, I just, we don't even like really go over it. You can answer it like that, or you could answer it like x plus 9 squared, which is what we want to do, because what we're trying to do is basically get in there and undo that parentheses squared. Okay? So I'd like to kind of tell you why we're doing what we're doing, so it kind of makes a little more sense. So when we learn how to complete the square, again, every method, all 4 of these methods have particular starting points. When you were solving by factoring, everything had to be on the same side, right? Remember that? That last one, whatever squared had to be by itself. Here, we want our variable terms, our x squared and x squared and x terms to be by themselves. We don't want a constant over there, like at all. Okay, because that constant throws off trying to create the number we're going to add to both sides. That's a perfect square number to make a perfect square trinomial, the way the math works. So we want to make sure that our x terms are by themselves, any constants on the other side, before we get to go complete the square. The other thing, sometimes I skip over a little bit too quick, is we don't want a number in front of x squared, just like we did on the square root property, right? So if there's a number in front of x squared, we would divide. But then we'll learn how to complete the square, and we're just going to go ahead and start doing that from here, and then I'll finish out the instructions. So like number 10 is already in the right spot. Our x's are already isolated, the constants on the other side. So that's good. So when we complete the square, I'm going to do that over here in a different colors, and you'll see that. What we do is we multiply the coefficient of x. It should be the only number you see over there now, which is a -8. Go ahead and take the negative with it. Just show that. We're going to multiply it times 1/2, which is like saying -8 divided by, I don't know why I wrote that negative, divided by 2. So what's -8 divided by 2?
-4.
-4. So once we multiply it times 1/2, we're going to square that result. So we're going to say, let's take -4, and it will always be a positive number. So what you do is we're looking at this -8 number, and we're multiplying it times 1/2. So -4 times -4 is what? A positive 16. This will always be positive. You're never going to have a negative number here. Like my positive word is very scrunched. So this is a number that you're going to add. That's what step C says. You're going to add it to both sides of the equal sign. So I'm just going to write that over here to the left so we have room. X squared minus 8x. And then we're going to write plus 16 equals that 20 plus 16.
Did you just put 36 there?
Nope, you can't.
You can't?
Oh, well, I mean, I guess you can. Sorry. You're like already adding. I thought you meant like
Yeah.
adding 36 to both sides.
No.
Yes. I mean, you could. Yeah.
Okay.
If you're just going to add it on your own, that's fine. You still have to rewrite the next step anyways. So, because now what we want to do is factor that left side. This is where I need to make a binomial squared. So, we would have x minus 4 in a parenthesis squared equals 36. And if you're like, wow, how did she get that so fast? Just think about it for a minute, and it will be a pattern that will actually come to you very quickly as you're doing these processes. If I take negative 4 times negative 4, always the same number because it's a perfect square times itself, does that make positive 16? When I add those, does that make negative 8? Yeah, so hopefully what we can do is kind of get a little bit better at factoring perfect square trinomials in this lesson so that we can just go straight to a parentheses squared. The other thing I'm going to go ahead and point out to you is when you're factoring it, the number in your parentheses is the number that you had before you squared it in your completing the square process every time. So that's also a pattern you could look at if you need to. So once we get it to here, we finish solving using that square root property that we learned on the page before.
16 and all that stuff.
So let's take the square root. So we have x minus 4 equals a positive 6, and x minus 4 equals a negative 6. So remember, we're doing a binomial squared, so it creates two equations, and you're going to have two different numbers. So we're going to add 4 to both sides, so x equals 10. Add 4 to both sides, x equals negative 2. So x equals 10 and negative 2. If you're entering it in WebAssign, I'm okay if it's on paper that you just box those out. You don't have to rewrite it. So that's just the first time we tried it. We're going to do it again, and maybe and it helps you pick up on the pattern, training your brain to think what step to think and do next. Let's look at number 11. Number 11, the x terms are not isolated, right? So first, let's move 144 over. When I'm moving it, when it's like this for me, I like to just go ahead and leave a space right there for when I add my number back in, because you know we're going to be doing that eventually. It's up to you if you leave a space, but I like to. So that would be equals 144. The other thing that we need to do in this one is get rid of the 2 that's in front of that x squared term. And so we do that by dividing every single thing by 2. So we have x squared plus 6x, I like to leave a space there, equals 72. So far, this one has been different from 10 because the x terms were not by themselves, and because it had a number in front of the x squared. So we did have 2 steps to start with before. Now we can go complete the square, and I'm just going to again write that and label it, complete the square. So when we're completing the square, we're looking at the number in front of x. So you're taking 6, and you can say, up here it says you're multiplying it times 1/2. which is the same as dividing by 2, wouldn't you agree? So you could write 6 divided by 2 equals 3. And then when we get that number, we square it because we want to be working with perfect square numbers. So we divide it by 2, and we get 3 times 3 is 9. So this is the perfect square number. I like to write a box around it. Kind of looks like a square. To remind me, this is the number that I needed to find that I would add to both sides. So add 9 here and add 9 here. I think on our final exam, I'll remind you this way later, but I think on our final exam when they talk about asking you a question about completing the square, they'll ask you what number do you add to both sides. That's all you have to do is say 9. Yes?
On the final, like, can't you just use quadratic formula to solve this?
You could, but that's why I'm saying that what I just said was when it's talking about completing the square, they want to be sure you know how to do this. So they don't actually have you solve it. They say, what is the number that you would add to both sides? Yeah. So that's why I'm kind of drawing attention to that a little bit now. And that's when you would answer, oh, you'd have to add 9, and then you would get to stop with that one.
Okay.
Yeah.
I got you. So it's not about solving it, it's about
Right.
just knowing.
Like when it comes to this method, what they're trying to be sure is you understand the concept of that. Yeah.
Okay.
But you're going to get practice of this method later in this unit anyways, so you'll even get better at it. Okay? So this factors into a binomial squared because it is a perfect square trinomial. If you take 3 times 3, you get 9. If they were both positive, they would add up to be 6. So x plus 3 in the parentheses, and 72 plus 9 is 81. So then we get to finish solving by using our square root property. So remember that this has a positive and a negative 9. So x plus 3 equals 9, and x plus 3 equals negative 9. So we subtract 3, so we get x equals 6. So remember, you get 2 different answers when you have these binomial squareds, and x would be a negative 12.
Here.
Do you see that 9?
Plus 9.
The last one, and I will tell you it's the ugliest one of them all. What I will do is go through it with you, but then kind of re-emphasize how I want you to be picking up on the pattern of the steps, the concepts. But this one, what's great about this one is the x squareds are isolated, but what do I need to do before I start completing the square?
Divide 4 on all sides?
Right, divide everything by 4. So maybe underneath there you have x squared plus 3x, I'm going to leave a space, equals 36 divided by 4 is 9. So what's kind of ugly about this one is when we go through our complete the square steps,
Ooh, it's going to be a fraction.
it's going to be a fraction.
30x.
3.
Yeah.
Over 2.
Yeah, so if I take 3 and divide it by 2, since I can't divide that, I'm going to leave it as 3 over 2, but I have to square it. When you square a fraction, it's just like you square each number separately, right? So what's 3 times 3?
You divide it by 1/2.
6? Or, no, it's
9, and 2 times
It's
2
what it says.
4.
is 4.
So,
We could do 3 times 1.
yeah. This is just perfect.
So again, if you, like up here it says divide or multiply times 1/2, right? I'm okay, I kind of did go both ways. Sometimes I always write times 1/2. But it's the same as dividing by 2 if you want to look at it as one less step. So here though, if it's 3 and you're dividing it by 2, I can't divide 3 by 2. So I just square it. And 3 over 2 times 3 over 2 is 9 over 4. So this is a perfect square fraction. So just think it's like an upstairs and a downstairs of a perfect square number. So we're going to add 9/4 to both sides. Again, concepts are the same, it's just a fraction. If you weren't sure how to square the fraction, you could do that in your calculator, right? Factoring also kind of helps if you were picking up on that pattern of you're going back to the same number you had before you squared it in your parentheses. So we will have an x, since that's a positive 3, plus 3/2. How does that ever create a 3? I'm glad you asked. I'm going to show you. So 3/2 times 3/2 is that 9/4, right? If we're adding these, they have a common denominator of 2, and 3 plus 3 was 6, which is that number 3. You don't have to go do all that investigating to prove it. If you pick out that we are using in our binomial squared the number we took before we squared it. If you want. And that's what I like to do. Right? It's the number that I squared in your parentheses. Jimmy, say that again? Maybe? Yes? No? Okay, yes. Most of the time I was looking at you and you're like, I'm not picking up on that yet. Okay, so you're looking at this and you're like, well, how do you factor that? That looks great. We can't factor fractions. We actually